It's fine,
Yes, sir.
sir.
Okay, recording up.
Yes, sir.
Okay. Vasudev, last class we were dealing with the communication system. By communication, I mean how is the wave to communicate on
Yes, sir.
Doppler ground. If you can recollect, we were referring to we were referring to wave equation, right?
Yes, sir.
And we got to know that there are 12 solutions in accordance. What we got to know was that if any mathematical expression can be expressed, any mathematical expression can be expressed in any of the 12 solution form, then that mathematical expression holds water or qualifies for wave equation expression, correct?
Yes, sir.
Sir.
That is what we got to know, and that is what we did advocate. We did advocate for standing wave. Why standing wave called a standing wave? Was the reason to give it an epithet of wave, right? Isn't
Yes,
it?
sir. Yes, sir.
Yes, sir.
I'm not able to see. I don't know how is Viva able to see. Viva, are you able to see all of us?
Sir, I put it on speaker view, so whoever is speaking, I can see them because it's convenient for me. You don't
I
need to
said,
put it. Yes,
I
sir.
said, are you able to see all of us?
Yes, yes, sir. I'm able to see everyone, sir. Yes, sir.
Okay, good enough. Good enough. Yeah, what do you call it? Vasudev, please record it. Kuldeep, I don't think has joined as yet. No, he has not. He'll be joining in few minutes, but he should not miss anything. So please record. Both of you,
Yes,
please do record.
sir. I
I'll
haven't
be recording.
prepared any
That's fine.
recordings to leave.
Viva, you do have, right?
Sir? Sir, I recorded, sir. I'm recording. It's showing the timing also.
Viva, can you hear me?
Yes, sir. I can hear you, sir.
Recording
I
is
rec-
on, right?
yes, sir. Recording is on 2
Okay.
minutes, 15 seconds on.
Okay. Now, and all of us should be present, right?
Yes, sir.
Now, what I was dealing the other day was Doppler's effect. We dealt with Doppler's effect, some part of Doppler's effect. Okay, Vasudev?
So I don't recall studying Doppler effect in the last class.
Okay. No, no, no. Not with you. You were not
Okay.
there.
Yes, sir.
With you, we did culminate at wave equation.
Yes, sir.
That was the last I did with you, with the two of you, that being wave equation.
Yes, sir.
So what you have is, of course, I'm not to let go. We will be recapitulating it for Vibha, and then we'll further. Recapitulation will not ask for much, just 5 to 10 minutes. Fine, dear?
Yes, sir.
Firstly, what is Doppler's effect? Is it limited to sound, or is an amorphous phenomena which relates to any wave? To which the answer is
Yes.
certainly it relates to any wave, be it optics or acoustic. Fine?
Yes, sir.
Be it optics or acoustic. It relates to both the ways. And last few years, it has gained traction vis-a-vis IIT, the factor that it is also to be related to optics.
Yes,
We have seen questions directly being asked on Doppler's effect vis-a-vis optics, not acoustic, but optics. Okay, dear?
yes, sir.
So I'll come to optics, but before of that, how do we read and analyze it vis-a-vis longitudinal wave, vis-a-vis sound wave, or acoustic wave? Fine, dear?
Yes, sir.
Now, what is this phenomena? Primarily, what is this? What do you mean by Doppler's effect? What is this? This is a phenomena which is based on relative velocity. I repeat, it's a phenomena based on relative velocity. By relative velocity, what I mean, between which two components? Between two components, A source, B observer. Find out
Yes,
what
sir.
is based on relative velocity between A, source, B, observer. Mind here, when they
Yes, sir.
move, what relative is the motion which exists between them. That relative velocity will have much say on frequency heard by the observer. Got it here?
Yes, sir.
The relative velocity will have say on frequency observed by the observer. And that is what we'll be highlighting in the study of Doppler's effect. Am I amply clear?
Yes, sir.
So what we do, we take one at a time and we'll club later. By one at a time, what I mean, I'll keep one object at rest and we'll move the other. Let us start with source being at rest and in motion observer. Find here. Let us
Yes.
start with what being at rest? Source being at rest and in motion observer. Let me be amply clear on what I'm going to present on board. I'll present on board a compression by a line. You're aware of compression means volume. Compression is housed by a volume. It encompasses a volume. Rarefaction also encompasses a volume, right? Yeah.
Yes, sir.
The body is volume, it's voluminous. We cannot say that compression is reduced to a line. But to represent on board, I'll be using one line to represent compression. Clear, dear? Just to represent on board, representation of compression will be reduced to a line. Fine, dear?
Yes, sir.
Let me make the point which I did emphasize the other day, yet again surfaced. And that being, as I told you, that will not be taken in class in general, so I'm re-emphasizing on it. When you speak, the way or the manner in which you are hitting wall is the manner in which wave will get reflected. If a compression is hitting, you will get a compression. If a rarefaction is hitting, you will get a rarefaction. That adds to, as we are aware of, why when a longitudinal wave is hitting relatively denser medium, there is no phase difference between incident and reflected ray. Okay, dear?
Yes, sir.
Which is certainly in odds with transverse, correct?
Yes,
Which is
sir.
in odds with transverse, diametrically opposite. Correct, yeah?
Yes, sir.
Okay. Just to re-emphasize on it. Back to what we are to take this day, Doppler's effect. And at a time, in isolation, I take observer to be in motion, source at rest. For source, I have a tuning fork, which is over here producing a compression C1. Somewhere is the tuning fork. It is incognito to us. I may draw. This is the tuning fork. Okay, dear. This is the prong of the tuning fork. Fine, dear. The
Yes,
prong of the tuning fork is being hit and it has moved forward. It has generated a compression. Okay, dear.
Yes, sir.
Yes, sir.
What will be time period for the prong to reinstate its position? Let us say tau. In tau time period, it will be back to this position. If it is back to this position, what will it do? It will generate another compression. Correct, dear?
Yes, sir.
No. But in that time, this compression, the compression that was generated at what time? T equal to 0. It is over here. The compression generated at T equal to 0. Where it is? It is over here. Find here.
Yes, sir.
Yes, sir.
I give now my observation a time tau. What is that time period tau? Time taken by prong to move back and forth. Is it okay?
Yes, sir.
Yes, sir.
In that time period, C1 will not remain there. C1 will travel with speed of sound. And where will it be seen after a time period? Tau, where what is tau the representation of? I have told you already. Tau is the representation of time period. Find here.
Yes, sir.
Yes, sir.
So where will C1 be seen? Let's say C1 is seen over here. C1 is seen over here. In the same breath, what I am to tell you is the prong. Now, capable of producing another compression, right dear?
Yes, sir.
Yes, sir.
Where will it be produced? At the same position where was C1 produced at t equal to 0, correct?
Yes, sir.
Okay, we marked it C2. You are also aware of distance traveled by C1 in a time period will be marked as V into tau, right dear?
Yes, sir.
Yes, sir.
Marked as V into tau. That is what is wavelength to us. That is what is wavelength to us. Fine dear?
Yes, sir.
Yes, sir.
Now there is a person standing out here. This person now starts running. Running with what speed? V naught speed. Running with speed V naught towards stationary observer. Okay, dear? Sorry, stationary source. Fine? Source is stationary, mind you. I told I'll be taking one at a time and then we'll club amalgamate later. So source is at rest, observer in motion, and observer is moving towards the source. Clear?
Yes, sir.
With what speed now the observer will interface wave fronts or compressions? What will be the speed with which it will be interfacing, interjecting, or meeting the wave fronts or compression? He was moving or seen to be moving with V naught towards source, correct?
Yes, sir.
And compression is moving towards him or towards them, correct?
Yes, sir.
Yes, sir.
Correct?
Yes, sir.
Yes, sir.
So with what speed will he find wave to be moving towards him or towards them? With what speed will they find wave to be moving towards them? What will you say? V naught plus V, correct?
Yes, sir.
V naught being the speed with which wave is moving, and V being the speed with which, wave is moving, and V naught with which observer is, right?
Yes, sir.
So what is the relative velocity of the wave? Relative velocity is V plus V naught. Agreement, same page, yes or no?
Yes, sir.
Yes, sir.
Okay. What is frequency marked? Frequency will be marked this divided by lambda. Lambda is not to change. I repeat, lambda doesn't change over here. Lambda will change, important point not taken in classes. Lambda will change when moves not the observer but the source. Lambda changes when moves not the observer but source. When only observer is to move, lambda doesn't change. When only source is to move, only then will change lambda. Am I clear?
Yes,
Yes,
sir.
sir.
We will highlight it, underscore it later. For now, lambda intact. Lambda, will be replaced by, to get greater understanding, I'll replace lambda by V into tau. Okay, V into tau. Clear, dear?
Yes,
Yes,
sir.
sir.
What do we then get to see? V plus V naught by V, and 1 into tau is nothing but frequency. Frequency of what? Frequency of tuning fork, natural frequency, or the frequency organic. Find here.
Yes, sir.
Yes, sir.
This is the organic frequency. This is what it is vibrating with. But this will be heard by the observer running towards the stationary source. Getting it? Please
Yes.
mark the operational word, stationary. Okay?
Yes.
So, what do you mean by
Very
organic?
good.
What do you mean by
Yeah,
organic?
F naught, you can mark it as F naught, is the organic frequency with which the prong is vibrating, right?
Also, we name that as natural frequency. That is a natural frequency
Natural
of the
can be
phone.
at time understood. Natural is what we all vibrate with. So it can be misunderstood. That's the reason I'm using the word organic, with which you have made it vibrate. Natural is with what all of us do vibrate. We have our natural frequency of vibration, correct? When natural is met with the window pane, if you have seen window pane vibrating with higher amplitude, why? Because the natural is then getting mixed or a match with what is forced by movement of a vehicle or aeroplane, then start vibrating with higher frequency, or we ask the troops to break their step when moving on a bridge, because if the troop frequency matches with bridge, then bridge will start oscillating with higher amplitude, thereby may be, am I audible?
Yes,
Yes,
sir.
sir. Yes, sir. Yes, sir. Audible, sir.
Thereby may be raised to rebels. Okay?
Okay.
So that is natural. That's the reason I'm refraining from the usage of natural, organic, with which you have made it vibrate. Find yeah.
Okay.
Okay, and this will be heard by the person. Which person? A person
The other
who
who's
is
running
running
towards
towards the stationary
source.
source. Clear?
Yes, sir.
It goes without saying, no brainer over here, that this will be higher than the organic. Correct? Yeah.
Yes, sir.
They may
Yes, sir.
ask at times mundane question, by what quantity higher, what percentage higher. You are capable to find it out, right? Because this is of the order 1 plus V naught by V, right? Right?
Yes, sir. Yes, sir.
So by what additional by this amount, correct? Yeah.
Yes, sir.
Okay. What if the source is stationary but the observer moving away? Of course, away, not more than V. If it is moving away more than V, then you'll get sonic boom. That is different. We'll come to that later. As of now, the observer is not moving with more than V speed. Then what you get is V minus V naught divided by V into tau, which will lead to V minus V naught divided by V, and 1 by tau will again be F naught, right? Yeah. Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Time it is of course less than by the same quantum, isn't it? Less than by the same quantum. So this is the usual practice. This is what is being very well elucidated in the class, not the other ones which are into coming. I'm coming to the other one now, one of the ones. Now, observer is at rest, source in motion. Case 2, observer at rest, source in motion. I'm erasing it off. Observer at rest, source in motion. Find yeah.
Yes, sir.
Okay. Let us take same position for C1. This is the position for C1 to begin with. Then is taken this position by C2. Where is C1? Over here. What is distance? This distance is lambda to us. Find here. Well, lambda is nothing but V into tau. We are aware of it. Done?
Yes, sir.
Clear?
Yes,
sir.
sir. Clear.
Now source. Am I audible?
Yes, sir.
Now we are to say, are you there, Vasudev?
Yes, sir.
Okay, now we have to say that observer is at rest, source started moving with a speed Vs. Okay? Source started moving with a speed Vs. And we're aware of that after one time period, source will be capable of permeating another compression. force will be capable of emanating another compression, right?
Yes, sir.
Okay. But where will that compression be? Where will C2 be after one time period is known to both of you? Where will C2 be after one time period is known to both of you? This is the scenario at what time? T equal to 0, let us say. Then after one time, mind you, at T equal to 0, C2 had no trucks with source. C2 left source, correct? And
Yes.
C2 will move with what speed? The speed of sound. So where will C2 be seen after one time period? What distance will it travel? It will travel distance v into tau. Where will it be seen? It will be seen over here, right? Yes, C2. Say yes or no?
Yes, sir.
Yes, sir.
Where will C3 be seen? Now what on earth is C3? C3 is the next compression. Which compression? The compression which will be generated by the source. What kind of a source? A source in motion. And between C3 and C2 generation, between C3 generation and C2 generation, you have a time lag of tau, one time period, correct?
Yes, sir.
So in one time period, what will happen to source? Source will move a distance Vs into tau. Agreement?
Yes,
Yes,
sir.
sir.
Therefore, C3 will not be permeated here. This would have been the position subject to source being at rest. Getting or not?
Yes, sir.
Yes, sir.
Which it is not. So where will C3 be? C3 be ahead of this position. Ahead by what quantum? Ahead by quantum Vs into tau. Am I clear, class?
Yes, sir.
Yes, sir.
Am I clear, Vibha?
So the C3 I am unable to
Huh?
understand. C3 is unable to understand, sir. I don't know
C3
what.
will not be over here because C3 would have been over here subject to source being at rest. Source is not at rest. Source is moving with speed Vs. And in time tau, it will move what distance? Vs into tau. So if source move forward by Vs into tau, then C3 will be produced at a distance Vs into tau ahead of the point of production of C2. Correct, dear?
So I'm just,
Correct,
Sir.
Vibha.
so I'm just trying to write it down. So
So this is what to us. This is now lambda prime to us. This is new lambda. This is new lambda. Is it okay, Vasudev?
Yes, sir. I just a little
Vasudev, is
question.
it clear?
Yes, sir. I have one doubt. Uh, if
Yes,
if
dear.
the, if the tuning fork was moving, then how did the distance between C2 and C1 stay lambda?
How did the distance between?
C2 and C1 stay lambda because even that would
C1 is
have.
ahead. This is the position showing C3 and C2. C1 is moving ahead, right?
No, sir. In the second diagram you've drawn, the C1, the distance between C2 and C1 would also have been
C2, I
lambda.
have not taken movement of tuning fork from here.
Oh, okay.
I have taken movement of tuning fork from here. Okay, dear?
Yes, sir. Got it.
You can mark it C1 if you want. No issues. Okay?
Yes, sir.
I'm taking a movement from here, from the animation of C2. Fine, dear?
Yes, sir.
If that is a contention, you can mark this C1, okay? And mark
Noted.
this C2. Fine, dear?
Yes, sir.
Okay. Now, what is lambda prime? How is lambda prime related to lambda? How is lambda prime related to lambda? Tell me. Look over here. I may use a different color. Look over here. This one. What is this to us? Visible?
Yes, sir.
This is lambda, right?
Yes, sir.
Yes, sir.
Right?
Yes,
What will be
sir.
lambda prime? Lambda prime will be lambda minus Vs tau. Okay?
Yes, sir.
Lambda prime will be lambda minus Vs tau. Clear?
Yes, sir.
And this is enough for substantiation. What is happening to lambda and when? Lambda is changing when source is in motion. Clear, dear?
Yes, sir.
Okay. Of course, now what frequency? Frequency will be V remains. V is not changing. What has changed? Lambda. It's lambda prime now. Clear?
Yes, sir.
Yes, sir.
Okay. What we have to write next? V divided by what lambda prime? Lambda minus Vs tau. You are aware of lambda. Lambda is nothing but V into tau minus Vs tau as it is. Vs tau and lambda is V into tau. Clear, dear?
Yes, sir.
Yes, sir.
What do we then get to see? It is being reduced to V minus Vs, and 1 by tau is nothing but the organic frequency. Please do check, class.
Yes, sir.
We get to see V divided by V minus Vs whole multiplied with the organic frequency. Right?
Yes, sir.
Clear? Clear, both of you?
Yes, sir. But sir, I had this question, if you don't mind.
Yeah, please do. What
So
will I
the-
mind?
So the thing is, when the source itself is moving, we've always been told that sound travels at a constant velocity through air, right, at a specific temperature. So why doesn't the moving source impart its velocity to the sound? Like, why doesn't the
Well,
speed of the wave
source-
become V plus Vs?
Right, right. What do we take? We take speed of sound in medium. We take speed of sound in medium.
Yes.
Now, if the medium is made to move or is being supported by wind, right?
Yes, sir.
Then it will change. It is not subject to movement of source. Speed of sound in a medium will remain what it is ought to be, and that will be 330, 320 around it, right?
Yes, sir.
When we say 320, 330, we are referring to we are the medium then. We are the medium, we are viewing it. We are viewing it to be moving with 320 or 330 meter per second. It will change if wind is supporting it, wind is letting it move with higher speed. When we refer to this, we are referring to medium being at rest.
Yes, sir. So then,
Yes.
so then the speed of sound relative to the moving source would actually be less than the speed of sound observed by a stationary observer.
Relative to the source, right? Yeah,
Yes, sir. It'll be less.
It'll be. Yeah, it'll be less.
Yes,
As
sir.
observed by a person. If I'm the source, I'm moving. That'll be less. But
Okay, sir.
we are referring to what speed? Just think about it. 330 meter per second, right?
Yes.
Isn't it?
Yes.
So we are referring to that speed. And not that being the case, how will you get sonic booms?
So, sir, at the point of a sonic boom, the speed of sound becomes 0 to the source.
No, we are moving with a speed higher than sound.
Oh, okay. So sound is moving relative to us in a negative direction.
Yes. Yes. Got it?
Okay. Yes, sir.
Okay. So this is what we have. Yeah, yes, Vibha.
Sir, actually,
Yes,
I
Vibha,
didn't
please
understand.
speak.
Sir, I didn't understand how the source moves. I came to
Yes,
know,
Viva,
but
I couldn't get you.
compression C2 and C3. I got stuck in between that. Like how C2 is being
Yesterday
moving
also we have
backward.
seen this, Viva. There should not be any point of confusion. You saw this yesterday as well. What is the problem between C2 and C3, dear? C2 was emanated at t equal to 0, okay?
Yes, sir.
C2 was
Okay.
animated at t equal to 0, fine.
Yes, sir.
Now, when C3 is emanated, it will have by then, it should have by then traveled some distance. It will
Yes,
have by then some distance to merit itself. It will have or not?
yes,
Because
sir.
it got what time to travel? It got time tau to travel. Tau is the time period. Tau is the
Yes,
time period taken by tuning fork to generate compressions, correct?
yes, sir.
So next compression C3 will be generated after of what time? After of time tau, correct?
Yes, sir.
So between C2 and C3 generation, what is the time lag? Tau, correct?
Yes, sir.
So in time tau, C2 will move what distance? It will move a distance V into tau, correct?
Yes, sir.
Correct?
Yes, sir. Yes, sir. Yes, sir.
So it has moved V into tau. This was C2 position. It is now to be seen where? Here. So what distance it has moved? V into tau, correct?
Yes, sir. Yes, sir.
And where will be C3 seen? C3 will not be seen over here. Why? Because this would have been the position subject to source being at rest. Source is not at rest. Source itself has moved forward. Correct?
Yes, sir. Okay.
That time, source has moved forward. Yes or no?
Yes, sir. Yes, sir.
Move forward by what distance? Vs into tau. Correct?
Yes, sir.
So where will C3 be? C3 will be at a distance Vs into tau, right?
Yes, sir. Okay, sir.
That is what we have shown over here. Fine?
Yes, sir. Okay.
Okay. Now schematic diagram for the other one. Write down case 2. Observer is at rest. Observer is at rest. And source is moving away from the observer. Observer is at rest. And source is moving away from the observer. Now please see to it that you get this one with clarity because I am taking it in isolation. You may be bogged with some of the argument which I'll be placing forth. As you may be of the opinion that why is there no intermixing. So let me be very clear. Firstly, I begin with. What do you want to begin with? C1, C0, what do you want to begin with?
C1.
C1.
Okay. Yeah.
C1, and where is C0? Over here is C0. Find here. This is position at what time? T equal to 0. Clear?
Yes, sir.
Both of you.
Yes, sir.
Yes, sir.
The time tau, tuning fork will be ready to permeate another compression, correct?
Yes, sir.
Yes, sir.
Okay. But in time tau, what will happen to C1? C1 would have moved forward. Forward by what distance? V into tau. Agreement? Where will C1 be seen? Here. Agreed?
Yes, sir.
Okay. And in the same time tau, where is the tuning fork to be seen? Where is the tuning fork now? Tuning fork was assumed to be moving backward, correct?
Yes, sir.
Yes, sir.
So if the tuning fork was over here to begin with, now the tuning fork is at certain distance and it is ready to permeate C2, right?
Yes, sir.
Yes, sir.
Or no?
Yes, sir.
Yes, sir.
Okay, I'm showing it by dotted line. What is this to us? This distance is Vs into tau. Is it clear, Vibha?
Yes, sir.
Okay. Tell me what will be the new lambda? Will this not be the new lambda? Because lambda is nothing but distance between two consecutive compressions, correct?
Yes, sir.
Correct? Vasudev?
Yes, sir.
So what will lambda mark now? Lambda prime rather, new lambda. It is lambda plus Vs tau, correct?
Yes, sir.
Yes, sir.
Okay, so lambda plus Vs tau. Lambda is nothing but V into tau, we are aware of it, plus Vs tau. Now we go to frequency, the new frequency. What will that be? V divided by V plus Vs, and 1 by tau can be marked as the natural frequency. Please do check. Getting it?
Yes, sir.
Yes, sir.
Is it clear?
Yes, sir.
Clear, Vasudev?
Yes, sir.
So, what is the formula which we get? Combining them all. V plus minus V naught, V plus minus Vs, all multiplied with the organic. Correct? Now let me ask you a question. How will you shape a case? Formula wise, what formula will you articulate? What will this form, this generic form, change to? What will this generic form shape to? If I'm referring to a case in which observer is moving towards source and source away from observer. Now I'm into mixing the cases. I'm into overlapping them, superimposing them, amalgamating them. Clear, dear?
Yes, sir.
Okay, sir.
Okay. Source, let's say, is moving away from observer and observer towards source.
Observer is chasing the source. Maybe we can say like that. Is
So what
observer.
say, what will this formula be shaping to? Observer is moving towards source and source away from observer. When observer moves towards source, what will happen to take in isolation, please? Otherwise, it will not add up. Take in isolation. First case, when observer is moving towards source. So observer governs numerator. We can see observer governs numerator, correct?
Yes, sir.
Yes, sir.
So observer moving towards source means frequency will increase, so plus. Correct?
Yes, sir.
Yes, sir.
And then to this I did add source moving away. If source moves away, then frequency will fall, right?
Increase. Yes, sir. So V plus Vs.
So we'll go with plus. So V plus Vs. This multiplied with F naught. Am I clear on this?
Yes, sir.
Yes, sir.
Am I clear on this?
Yes, sir.
Yes, sir.
Okay. Now to the point, not del anywhere. Very important. We will go to the last bit of dissection on it because not dealt anywhere. And so much so is this import that, so much so, the one that we'll be dealing is the import that S.T. Verma changed one of its question. S.T. Verma has changed in his book one of the question, which earlier was having a different answer. Now it is having a corrected answer. So we are going to refer to a very important case, and the case being what happens when wave is getting reflected. What frequency you will hear when wave is getting reflected. Let me take a simple case first. Let us say wave is getting reflected from a stationary wall. India?
Yes, sir.
Standing, I'm generating a wave, I'm not moving. wall it is hitting and getting reflected. What frequency I'll hear? Same what is being generated by me. Agreed?
Yes, sir.
Yes,
Yes
sir.
or no? I'm not
Yes.
moving, neither is the wall moving. So wall is reflecting, I will be observing same. Reflected wave will have the same frequency measurement what being generated by me, correct?
Yes, sir.
Yes.
Now if I start moving, running towards or running away, then what the case? Simple. In the case in which wall will do a source, correct? You will assume wall to be a source and source being at rest. Clear, dear?
Yes,
Yes, sir.
sir.
Please be mindful of what I'm speaking, dear. What did I do? I started running. Tuning fork where? In my hand. Where is the tuning fork? In my hand. What did I do? I started running towards wall. Fine.
Yes, sir.
Now what will wall do? Wall will simply mirror it. What will wall do? I repeat, wall will simply mirror it. By that what I mean? What will you see in wall? You will see your reflection in wall, correct?
Yes, sir.
Yes, sir.
So it will be the case wherein source, as you are holding the source. So source is moving towards you, correct? And
Yes,
you
sir.
moving towards source, right? Yeah.
Yes, sir.
Source moving towards you and you moving towards source. Say yes or no?
Yes,
Yes,
sir.
sir.
So what will be the equation? The equation will be V plus V naught divided by V minus V naught, correct? Source is
Yes,
moving
sir.
with the same speed, correct?
Yes, sir. Both
Yes,
effects
sir.
tend to increase the frequency.
Yes. Got it? So that is what will be heard by me. Am I clear?
So could you
Yes.
think
That is
about
what.
it this way? Like, for example, you're running towards a mirror, you are the source, your image is the observer.
If I'm running towards the mirror, then I'm holding it. But what will I see? I'll see the source running towards me, correct?
Yes, sir. Could you treat your image as the observer?
No. Image I will not treat as the observer.
So why is that?
I will not
Because it,
treat image as the observer. Observer is undeterred. It's me. I'm recording.
yes, sir.
That is virtual. That cannot record. It has not got a recorder, right?
So never like it would be equivalent to saying that you're listening, right?
The image is listening.
Yes, sir.
Yeah, it will be the same, right? That will not change.
Yes, sir.
That will not change. It will remain. Okay? We
Yes,
can
sir.
also assume, want to take it that way, we can also assume that there is a source which is wall and wall is at rest.
Yes,
I'm running towards it. Okay? Equally viable.
yes, yes, sir.
Then we'll get all the more clarity on it when I make wall move. Now I'm making wall move. Write it down, please, and this is important. Let us assume, write down, let us assume wall or screen to make it realistic. Let us assume wall in the bracket screen is moving towards the observer, who is holding the tuning fork, If the speed of wall is u, find frequency of reflected wave finds frequency of reflected wave heard by the observer. Heard by the observer. Am I clear with the question?
Yes, sir.
Yes, sir.
Now the case. Goes without saying, it's important. It won't get you anywhere. If you get, bring to my notice. Okay, what is it? I begin with a wall here. Wall. Near to wall, what compression you have? C0. Fine. Where is T1? Here. Clear, dear?
Yes, sir.
Clear? Am I clear with this? Depiction
Yes, sir.
first. At C equal to 0, what event has taken place? C0 has got reflected. Find here.
Yes, sir.
Yes, sir.
At T equal to 0, mind you, C0 got reflected.
Yes, sir.
It has undergone reflection. Okay. Now I take an arbitrary time T equal to T. Any time, it is not tau, mind you. It is an arbitrary time. Okay, dear?
Yes, sir.
T equal to T. In this time, what is so special about this time? This is the time when C1 meets the wall. Now, where is the wall? Wall is somewhere over here. What distance will this be? I have told you speed of wall is u. So what distance will this be? U into t. Agreement?
Yes, sir.
Yes, sir.
And what did I say about t equal to t? This is the time when C1 hits the wall or meets the wall, correct?
Yes, sir.
Yes, sir.
Okay. What about C0? T0 was reflected at t equal to 0, and this is the depiction at t equal to t. So C0 got what time to travel? Time t, small t, correct?
Yes, sir.
Yes, sir.
And C0 will travel with what speed? The speed of sound. So where can C0 be? Let us say C0 is over here. Then how much will this distance be? It's known to you. Tell me, what will it be? V into T. Agreement?
Yes, sir.
Yes, sir.
Okay. Also, dear, what is this distance? Do check. This 2 is V into T. Do check.
Yes, sir. That's
Or
also
no, because C1 got what time? Same time t, moving with same speed v. So C1 would have traveled what distance? Same distance v into t, right?
Yes, sir.
Yes, sir.
Check the depiction. Clear?
Yes, sir.
Yes, sir.
Clear, dear?
Yes, sir.
Yes, sir.
Okay. Now, is this clear?
Yes, sir.
Vasudev, Vibha.
Yes,
It is,
sir.
sir.
Okay. This we know, I'm using white color now. This we know is lambda. And what is lambda prime? We are aware of lambda is distance between two consecutive wave primes. So C1, C0, they are consecutive and they are after of reflection to be taken. We are taking it after of reflection. Therefore, what is this to us? Lambda prime. Check class. Right?
Yes, sir.
Right?
Yes,
Yes, sir.
So what is lambda? Can you help me with lambda? Yes, dear. Who will help me? Can you
Okay,
hear
just
me? Both of you?
a small clarification. The source is not moving, right?
Yes. Yes, dear.
The source is at rest, yes?
C1. This is the situation in which I'm not taking source into consideration per se, dear. Source will be factored in later. Fine, dear?
Yes, sir.
Is only wall in motion as of now.
Yes,
I
sir.
factor in source later. Got it?
Okay, sir.
Now, what is lambda? If you can look into the figure, if you can look into the schematic diagram as we call, then lambda is this, and lambda can be written as Vt plus Ut. Yes or no?
Yes, sir.
Yes, sir.
So we write lambda as Vt plus Ut. Now I go to lambda prime. What can lambda prime be marked?
Vt minus Ut.
T.
Et, this is lambda prime. You can see for yourself right here. So this is Vt minus Ut. Vt minus Ut, right?
Yes, sir.
New frequency. I write over here. Frequency now. What will it be? V divided by Vt minus Ut. Please exercise caution. Don't write 1 by T here as frequency because this T is arbitrary. It is not tau, right?
Yes, sir.
So how we will get an idea on T from the first equation, correct?
Yes, sir.
What is T from first equation? T is nothing but lambda divided by V plus U. Do check. Correct?
Yes, sir.
Yes, sir.
Correct?
Yes, sir.
Yes, sir.
We place it over here. What do we get? V divided by V minus U and 1 by T. 1 by T. So V plus U by lambda. Yeah?
Yes,
Yes,
sir.
sir.
Which will get us V plus U divided by V minus U and 1 V by lambda is nothing but the organic frequency, right dear?
Yes, sir.
Right dear?
Yes, sir.
Am I clear?
Yes, sir.
Can I get a thumbs up?
Yes, sir.
Am I clear?
Yes, sir.
Yes, sir.
This will be the frequency. Now, write it down. Amply clear over here. Make this point amply clear to yourself. Underscore it, please. This is the frequency which we can associate with moving wall. This is the frequency which we can associate the move with the moving wall. Thereby analogy, there being a stationary source, thereby analogy, there being a stationary source, exhuming this frequency, mind you, we have already taken motion into consideration, right?
Yes,
We
sir.
have already taken motion into consideration. We are not to redouble it. We are not to redo it. We are not to overplay it. Is it okay, class?
Yes, sir.
Yes, sir.
So now what the wall is to do, what is wall to you? It is a stationary source. What is it to you? Stationary source, which is exhuming what frequency? This frequency. Am I clear?
Yes, sir.
Yes, sir.
Now going back to the practical scenario. What was it? I was holding the tuning fork, correct?
Yes, sir.
Yes, sir.
And I was moving towards moving wall, correct?
Yes, sir.
Now moving wall has lived its utility. Can we say that?
Yes, sir.
Moving wall has lived its utility. It has lost relevance now. Correct, yeah?
Yes, sir.
Movement has lost on us. It has lived its utility. Now what it is to do, a stationary source. Agree?
Yes, sir.
Yes, sir.
Stationary source permeating what frequency? This one,
Yes, sir.
right?
Sir.
Right?
Yes, sir.
Yes, sir.
And what I'm doing, being an observer, I'm moving towards it, right?
Yes, sir.
Yes, sir.
So, what will be the denominator governed by? I'll come to that later. First the numerator. Plus or minus? Plus or minus? I'm moving towards source, correct?
Yes, sir.
Yes,
Plus.
sir. Plus.
What will it be? Plus. So V plus V naught. And then what about source? Source is at rest, correct?
Yes, sir.
Yes, sir.
So V. But what about frequency which I write over here?
Yes.
One which the stationary source is permeating, which is what to us?
V plus U by V minus U times.
Yeah. V plus U divided by V minus U all into the natural organic. Correct?
Yes, sir.
Yes, sir.
Am I clear on this part of theory, dear? Very important.
Yes, sir.
Yes, sir.
Yeah,
Yes, sir.
Yes, sir.
I wish to get from both of you schematic diagram when wall is moving away, not to the left, but to the right. Can you draw the schematic diagram? I know you'll be able to get me the formula. I'm not lynch-pinning it on formula. Rather, the fulcrum of the argument is on schematic diagram. There lies the crux. What's the time, please, both of you?
Sir, 2040.
Okay.
Eight.
Tell me, dear. Quickly, if you can, schematic diagram. Where will the wall be? Wall will be to the right, correct? Yeah.
Yes, sir.
Yes,
What
sir.
distance the wall would have moved by in time t, ut. Again, what is time t here? Time taken by which one to hit the wall, which compression? C1 to hit the wall, correct?
Yes, sir.
Yes, sir.
Okay. So you know what to mark Vt. Accordingly, you will get the new lambda as this time Vt plus Ut. Are you in subscription to what I've said? Check, dear, check. Vt plus Ut. Can I draw?
Yes, sir.
Or you
Yes,
will
sir.
be positioned.
We got it. I mean,
Can I
I got
draw?
it.
You got it.
Sir, I'm unable to, sir. I'm
Okay.
unable to.
Try, dear, you try. Nothing in it. There's nothing in it. Just T is the time taken by C1 to hit the wall. T is the time taken by what to hit the wall? C1 to hit the wall. And where is the wall? Wall has moved to the right. By what distance? U into T. So here is wall and here is C1, correct? Because we take time T for C1 to hit the wall. Clear, dear?
Yes, sir.
So what is this now? This was the initial of C1. What will be seen? There will be seen now C2. Okay.
Yes, sir.
Yes, sir.
Where is C naught? C naught I'll come to later. Other I'll not. I'll ask you where is C naught. Let me remove C2 for now. Where is C1 to be seen is clear. Yes or no?
Yes, sir.
Yes, sir.
Okay. Now what distance C1 would have traveled in time t that you can show? From here it started its journey. So how much is this distance? This distance is v into t, correct?
Yes, sir.
Yes, sir.
Okay. What about C naught? C naught got the same time t, correct?
Yes,
So
sir.
C naught will travel the same distance in the backward direction. And this is what I was referring to. Of course, we can grow our brain and say, how is that possible? They will get mixed. But I am assuming them to be immune to each other. So where is C naught? C naught got reflected at t equal to 0. It got what time? It got time t. So from this position, it will come to this place wherein the highlighted distance is nothing but v into t. Correct? C1 travels same distance as C naught. This is C naught. Agreement? Yes or no?
Yes, sir.
Yes,
But won't these waves interfere with each other?
That is what I said. I am taking in isolation there. Of course they will. Okay? But we are
So
assuming
how
it to be for understanding.
so how representative of reality
Okay? They
is
are
this?
binary, mutually exclusive event is what being touted.
Yes, sir.
Okay?
How much of a representation of reality is this?
Of course, the complete representation of reality, because this is what will make you understand how do we develop the formula.
Yes, sir.
That formula will not get developed otherwise. This is the development of the formula. It may be just possible that I have generated and moved away. Okay?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Okay.
So you've only
So what is
generated two waves and then the source has disappeared.
Yes. Yes.
Yes, sir.
Right.
Yes, sir.
So what is new lambda? Tell me lambda prime. C naught, C1. What is the distance? You're aware of. Tell me how much will it be?
Vt plus ut.
Yeah. And what is the old lambda? That also can be gotten from here. Old lambda being this, right? This is the old lambda. Please do check class. Old lambda is Vt minus Ut. Agreement?
yes, sir.
Yes, sir.
So old lambda is what to us? Vt minus Ut. And new lambda from here to here. From here to here. What is that? Vt plus Ut, correct?
Yes, sir.
Yes, sir.
So lambda prime is what to us? Vt plus Ut. If you'll go ahead with it, the only factor which will change over here is swapping of symbols. This will take minus and this will become plus.
Yes, sir.
Okay, dear?
Yes, sir.
Okay, this is what we keep to today. We'll be looking into questions. I'll get you questions the other class and we'll further to beats. Yet another topic. Generally I will say students are being pulled wool over their eyes on these factors. So we will be trying to make it threadbare to you. Okay? Each and every part being accordingly exhibited over here.
Yes, sir.
Let's call it a day. Thank you, class. Thank you, both
Yes,
of
sir.
you.
I had just one question. Um, what about the math
Yes,
classes
yes,
that
yeah, please.
also came with the course?
Yes, It will be. You'll be informed about it. You'll be informed about it.
Yes, sir.
I'll be
Thank
keeping you posted. I'll be posting you. Okay.
you. Yes, sir.
Okay. Thank you. Take care, both of you. Bye.
Thank you, sir. Good
Thank you,
night.
sir.
Thank you. Vibha.
Yes, sir.
Vibha.
Yes,
Yeah,
sir.
please share the video with me. Okay. Please share the video.
Sir, the Skype only will share the video. It'll do it automatically, sir. Within months.
It'll do automatically. Thank you, dear.
Yes.
Clear, right? Any doubt, dear?
Yes, sir.
Any doubt,
Yes,
please
sir.
do ask. Exclusive
Yes, sir.
time for you. Tell me.
Sir, I got my HC Verma today, and I finished up to the started off exercise 4.4. I'm still on the completion. It's taking a lot of time. I have to do some. Again, the college gave us
Why
assignment
is
and
taking
saying,
this length of time, Vibha? Why is taking higher than what is desired?
so it takes some time. So I had to look through. I had to look through the theory also, and then go move forward. They give an example and all. That's why I saw. So this is the first time I'm doing this chapter, so that's why.
Okay, and what about being taken the class today? All clear? No doubt?
No doubt, sir. No doubt.
Okay. Thank you, dear. Thank you. Take care.
Yes, sir. Yes.
Yeah.
Actually, I will be going out for one night. Hello, sir.
Yeah. Say.
So I'll be just going out for some half an hour outside because I need to get some stuff of mine, buy some
Yeah.
something because the books are
Yeah.
running out.
Both of you can ask for any doubt. There is any doubt, you can ask. Thank you.
Thank you, sir. Bye, sir.
I will be recording on the same group here, yes.
What?
I just wanted to ask about the recording. Because you're
The
recording the
recording
class.
Yes, sir. I was recording. I'll send you the call for that.
Yeah, okay, thanks.